Hi all. So in this video, we're going to be talking about discrete distribution. Discrete distributions, I guess. But in essence, we're going to talk about. We'll see. So in the last video, we talked about geometric distributions, and one of the things we can notice is that we can let k be any number, but it's not that. So in other words, we don't necessarily have some finite thing. We can let it be any arbitrarily large number. So basically this next step and the thing we're going to start doing is we're going to look at distributions from a discrete angle. And that's going to be most of this week's talk. So a discrete distribution is basically a probability distribution where the sample space is a set of non-negative integers. So basically we have anything that's done on these numbers. And each of these is going to have some probability associated to it. Where each one of these, so again, because it's a distribution, we need the three terms, right? So we need each of these to be greater than or equal to 0, and we need the sum of all of them to be equal to 1. So we've kind of seen some of these before. So here's like 5 different examples. So discrete uniform distribution, this is like rolling a die, right? Here you might be like, wait, but we only have like 6 things if we have a fair die. This is saying an infinite number of things. Well, in this case, what we have is P1 equal P2 equal P3, right? This is the uniform part is equal to P6 is equal to 1/6. And Pi is equal to 0 for all other I. So this is the kind of thing we kind of do. If it's a finite thing, we just say it's 0 everywhere else. And then in our little finite space, that's where it's non-zero. So Bernoulli distribution, this is another one. So this is like flipping a coin, if you remember this. Flipping an unfair coin, because the probability might change. Binomial distribution, I think we've seen this multiple times. So here we have n independent trials of a Bernoulli distribution. Geometric distribution, this one we just saw. I guess better say multiple trials until certain outcome. And this is with replacement, right? Because with the birthday problem, we did without replacement. And technically, the Poisson distribution is a discrete distribution as well. So why is this one discrete? So if you remember the formula for this is e to the minus mu to the k factorial. The reason why this is discrete is because of the k. So normally we look at p of x is equal to k. And k is always an integer. Mu might change, but k itself is always an integer. And so since this is an integer, Poisson, which technically has like some smooth graph, and we'll look at this later on, Poisson distribution is technically a discrete distribution. So it's kind of fun to see. So one of the things we're going to need to change a little is, remember how we're kind of saying, well, I want my sum to be equal to 1, right? And I still haven't really gone over this, because there was a third parameter, right, in our distribution definition. We also need that partitions need to behave nicely, right? But we could have an infinite partition. And so this is something we hadn't really discussed beforehand. So there's one other rule we need to add, and that's the infinite sum rule. And this is where our distributions are basically going to fix themselves. So this infinite sum rule is basically saying if an event can be partitioned into this. So remember here, AI square cap AJ means that A means basically we take the union of AI AJ such that AI and AJ are disjoint. So there's nothing between them. then what we're saying is if it can be partitioned into this infinite set, then we can just let P of A be the sum of all of these things. And yeah, so this basically gives us our three rules, and we're done, right? So the three rules, if you recall, are non-negative. So non-negative, I'll write them here. So non-negative, this was that first condition, and we did total sum, right? This was the third condition, and we just added the second condition, which was addition. So we now have the three conditions to have a distribution. And in particular, any finite distribution, so I think we kind of talked about this before, any finite distribution is going to be a discrete distribution. So any finite distributions are discrete distributions. And so like here I give the actually same example of rolling a die, and I say, well, exactly kind of what we think. So if the probability of everything being 1 through 6 gives me 1/6, and then everywhere else I just get 0. So yeah, so I will stop here for this video. We'll look at an example of this in the next video. So I will see you then.